today, and we're going to be talking today about SQL and how to produce good SQL, how to make sure that the SQL you have, what does it mean to run SQL, and so on. So I just thought I'd dive in. If you have questions, please ask. If you have no idea what I'm saying and don't understand, I'm sorry. If you start falling asleep, and I have things to throw at you, especially as I will practice, this is what I would do. I will take something and I will throw it at you. If you ask good questions, I will also throw candy at you. So if you're hungry, think of a good question, and then you can ask me, and then you can get a quick snack before the break.
So question is underhand, but if you fall asleep, it's like...
What's overhand? Yes, exactly. I throw gentle for good questions. If you snore, then I throw 2 or 3 to wake you up. Are you trying to get me to spill it? Okay, I'll get started. So can everyone see with the light? Is that okay? Very good. So in the next 2 hours or so, depending on, again, how many questions you have and how many of you fall asleep, the kind of things that I'm going to be talking about is when you have a SQL statement, what actually happens when you try to execute it. We're going to talk about what is the Oracle Optimizer. Everything today I'm going to talk about is primarily Oracle specific. Obviously, a lot of the things I will talk about apply to DB2s, MS SQL Server, and so on. But the examples are all using the Oracle syntax. But the general principles still apply. What is an execution plan? We're going to learn all about execution plans for SQL statements. You're going to be able to learn how to identify the plan for any particular SQL statement. What are good plans, what are bad plans, how to tell that this is a bad, annoying, troublesome SQL statement, and how to tell if something is actually a good SQL statement. Figure out when you should rewrite it, how you might want to rewrite it, what kind of indexes exist. Indexing is one possible answer to help produce good SQL statements. And then what other changes can I do to tune my application that are not even related to SQL itself? Obviously, I'm going to be focusing on SQL, but the application, you need to sort of have a bigger picture when you architect what you're doing. Everyone still okay? I need heads nodding. Okay, very good. So, the first thing is, what is a well-formed SQL statement? I have to define that. So it's a SQL statement that retrieves whatever data it needs with a minimum amount of logical and physical activity. So logical activity is sorting and playing in memory and moving things around, and physical activity is actually physically going to the specific blocks in the operating system on that disk somewhere and reading and doing I/O. And the idea is we want to be able to, from when we request it to when we get it back, we want to have the minimal amount of resources used, because then therefore we have a good statement, it goes faster, it doesn't take as many resources, we can have more statements running, our application runs faster. So this is sort of the basic goal at the high level. So the first thing to sort of discuss is what actually happens when I try to execute a SQL statement. If I make a JDBC call and I put a string in some string buffer, which has got all those characters, what actually happens between the time that I sort of fire that function and I actually get data back? So a lot of things happen. The first thing is we need to understand some sort of connection. So what is the database and the database account that I actually want to execute this statement? Where should this statement run? The second thing is, within the database itself, we create what is called a cursor. So this is in the database engine. It allocates space, and again, you can reuse cursors, potentially. We can talk about tuning to reuse cursors, that way you don't allocate and deallocate and fragment your cursor space. But a cursor is actually a little working area in Oracle itself, on the server, wherever Oracle is running, where actually all the work happens. That's where the data is read and stored temporarily. That's where you do sorts. That's where you do filters. That's where you do all sort of massaging. That's the working space of the database. It's called a cursor. What happens is, the first thing the database does is it parses the statement. What is that buffer of text you did? So it translates that text buffer into, this is a table, and this is a column, and these columns are in these tables. And so it tries to understand all that text that you put. These are formulas, these are functions, these are a package that's a stored procedure. So it tries to understand whatever's in that sort of text string that you do. And then it says, all right, now that I know all that, I'm going to plan a path. It's called my plan. I mean, it's really called the Oracle plan. And how I'm actually going to translate this sort of pile of tables and columns and so on into actually getting the data and making sure it's the exact right data that matches whatever constraints and criteria you put in the SQL statement. then it does something called defining and binding. So it's basically figuring out what are the columns requested. If you have things, variables, what are the variables bound to? Then it executes the statement, which is where it actually does all the work. And we're going to spend most of our time focusing on what happens here in the execution of the statement. And then it actually fetches and returns the records, and returns the data to the requester. And it may return it in one buffer or many buffers. You may ask for all the data. You may ask for the first 10 records, the first 100 records. You may, all that kind of stuff. So that's what happens at the high level. So now let's talk about tuning. So before we talk about tuning SQL statements, you have to understand you could tune everything in the entire stack. So it may not be the SQL statement itself that might be causing the problem. It might be something in the operating system or your network. You may not have the right disk, or the CPUs, you may not have enough resources. You may want to focus your energy, what is the general I/O? How did I lay out my disk? So there's lots of stuff there, which I won't be talking about, but that's a very important area. Then you have to optimize your database itself. So when I have data that I store a record in a table, that record has to be written somewhere in the operating system. And the operating system doesn't have the concept of tables, it has the concept of blocks. And so you send a block, whether it's 4,000 bytes or 8,000 bytes, depending on how you've partitioned your physical disk. It's got to compact these things and shove these little records, whatever might be in your database, columns in a table. It's somewhere in some formula, it puts that into a block. And I'll talk a little bit about that later. But how you actually set the size of the blocks and how many connection pools you have. In other words, you might have perfectly good SQL, but because you say only one user can connect to this database at a time, and you've got 10 threads in your application, they may be waiting for each other. Has nothing to do with the SQL. They may just be waiting for a connection to the database. So these are all things you need to look at. Then you have the Oracle Optimizer. That's sort of the brains of the system. The optimizer is what takes the SQL, parses it, figures out the plan, figures out how to get the data, gets the data, sorts and filters, and we'll talk in more detail about it. So you want to tune the optimizer, and you want to make sure that what the optimizer uses to make its decisions is available. Sometimes it uses statistics on tables, sometimes it uses hints, sometimes it uses how you've constructed your SQL statement, which when you have a from clause and you say from table 1 and table 2, that might produce a different plan for the exact same SQL when you have a from clause with table 2 and then table 1, because it tries to look and use your clues that you give it. So these are things to look at. And then you actually have your actual SQL statements themselves. So you want to make sure they're properly defined. Are you using indexes? Are you using materialized views? Do you want to, maybe if there's a complicated calculation or aggregation, that you do some sort of pre-aggregated table. You might want to denormalize some of your data. So there's a lot of things, and we'll get into more details. But we're today primarily going to be focusing on this and things to look at. Everyone's still awake? Doing okay? I'm not moving too much to mess up like the camera, so you have like half my head for one, just my top. So this is just another view of looking at the stack. Again, you want to go from the disk, RAM, CPU. There are different tools you can use to actually tuning the database instance itself. You want to tune the physical objects. What are the tables? How did I build the table? How do I construct the different indexes? What kind of indexes am I using? And then you actually have the SQL statements themselves. And so sometimes all the best work can be done in these. Sometimes you need to work in here. So this is the Oracle Optimizer. It's called the CBO, which stands for Cost-Based Optimizer. Databases actually sometimes, particularly Oracle, actually have a couple optimizers. Historically, through version 5 or version 6, there was no optimizer, or never worked, so no one used it. It had a rule-based optimizer. So it looked at the SQL statement and it constructed its own plan. In version 6, Oracle improved its optimizer significantly, and by version 7, it was actually one of the best optimizers out there, particularly since its competition, which was Informix, kind of disappeared. So the optimizer, which is really the brain of the system, takes lots of different settings. So it takes statistics on each of the tables. How is the data, how is the data distributed, for different columns, is it sparse data, is it very dense, are there a few values, and so on. It takes information about the specific columns, about the tables, how many rows, how they're done. It takes different configuration settings, how often you should cache data, whether you should be running in parallel, whether you should be reading data in multiple blocks or just read individual blocks, and that really depends on the SQL you do. It takes all sorts of information about the operating system, about the disks, and feeds all that and generates a plan. And that plan is basically, the plan is the recipe. And once it has a plan, it knows exactly what to follow, and it knows exactly what to do. And so now we're going to talk a little bit about the plans. So, general, this is sort of a high-level common sense kind of thing. What do you do to tune SQL? Well, first thing you have to do is identify what is the highest impact SQL. Which SQL statements are costing, by some definition of costing, the system the most. And then once you have the most offensive, annoying SQL, we'll find the plan, we'll tune that SQL, and then we retest. Because it may very well be that the fix for this SQL may not be rewriting the SQL, maybe adding an index somewhere. And that index we added may actually hurt other SQL statements, or may solve a whole bunch of SQL statements. So you just want to retest and find the newest high impact, and you just keep iterating over and over again. It's like, you shampoo your hair, and then you're supposed to repeat, and the instructions say shampoo the hair, and then you repeat, and you could be shampooing all day. So, here's the question. How do you identify the highest impact SQL? How do you find the statements you actually really want to spend your time focusing on and fixing? So, the highest impact SQL could be a variety of different things. It might be a small, tiny, very fast, extremely lightweight SQL statement that gets executed millions and millions of times. So you might have a simple lookup that's using an index, a primary key. It looks up just a tiny amount of data, so the amount of data is very light, but you're just querying it over and over. You do these lookups all the time for everything. So maybe the solution for this one is not even tuning the SQL, it's just read all that stuff, cache it in memory. So that's one possibility. You might have some other expensive statements, like you might have some complex report. And behind that report, you have a very complex query that looks at 7 tables and does all sorts of join conditions and sorts and filters and loops, all that kind of stuff. So when you run it, it just hammers resources and takes over a thread and stuff. But in reality, maybe that report's only run once a month. So it'd be nice to fix it, but if you can say, all right, I'm just going to run that report just at night, maybe you can tune it. If you can tune it, that's great. But maybe if you just run that report at night, you don't have to spend any time on it. Or just run that, once a month on a weekend. So it doesn't really help. So usually the most expensive impact statements that you really need to spend a lot of time tuning, it's sort of a combination. It's something that's run pretty often, and it's kind of painful to run. It just uses too many resources that you don't need. So the way you figure this stuff out is you actually look in the database itself. So the database is, to some degree, like the government. It keeps track of everything it does. And it throws it all over the place, and you have to be smart to kind of find and figure out what's useful and what's just a lot of noise. So it keeps track of every SQL statement it runs. It keeps track of all the work it had to do. So for every statement, it keeps track of how it executed, how much time it took to execute, what the plan was, how much data it read from each table, and that means like how many blocks it read in the disk, how many blocks it already had in memory because that statement had been run or parts of that statement had been run in memory, how it did sorting, how it did filtering. All this information, all this audit trail is actually stored in the database. It's got a collection of statistics objects. So VSQL area is a view towards all the actual SQL and every SQL statement you run, so you can actually find all the text of all the SQL statements. So you can find out, what you did run against the database, and oops, someone ran a delete statement that they shouldn't. You can actually figure that out by looking through their history. And you've got a collection of different summary objects that summarize all the statistics. So you look at the statistics, and you see how many rows are processed, how many buffer gets are, how much time I physically read from the disk. How much memory was used, how much CPU was used, how many times I did sorts, how many lines, were run, how many times I actually executed this exact same SQL statement. And you can use this to identify what has the highest cost in the system. And Oracle and all the other databases provide packages that used to be called bstat, vstat, and there's sort of a more modern name, version 8. It's part of some of it's part of the analyze package, part of the admin control panel, where you can actually look and get these things and run these statistics for an actual production system. You want to do it on a production system, in order to find out what is the most offensive, what is the most painful. So, once you have a particular statement in hand that you want to fix, and you can't eliminate it through caching, what you do is, we'll look at the execution plan. So the execution plan is whatever the path the engine takes to walk through indexes, blocks, and the table storage, to fetch and then sort the data, to actually get the data that you need and that you want to use. So, how would I figure out what the plan is for a particular statement? I've got a statement, it's very expensive. It takes a lot of disk, it takes a lot of I/O, the CPU spikes every time it runs. How can I figure out what the plan is? So, you have the concept of what's called a plan table. So a plan table is basically a table that comes that when you ask the optimizer, it will actually tell you, here's the plan for this statement. Here's what I'm going to do with that statement. So you can actually build the table, comes with a script, and there are a variety of different scripts, and you can sort of look on the internet for what the plan table looks like. It's in this sort of utility explain plan script. That's what it comes with in Oracle under the database directory. You create a public synonym for it so all your users can actually have it, because when you run the plan, it wants to know what objects you have to have access and privileges on the objects. And this is sort of some of the main columns in the plan table. There's probably another dozen more that are not really as useful or as important. So, just sort of briefly going through it, you've got the statement ID, which tells you what SQL statement you're actually running a plan for. One very common tuning thing that you can do is, you can look at all the statistics for all the statements, like we talked about earlier, or you could say, all right, maybe the database hasn't run, it's been shut down recently, or I'm just running this sort of in a test environment, so I don't really have good statistics, I don't have large volumes of data. So what you can do is you can basically go to that $SQL area, which has all the SQL statements that you run after you run your test, and say, for every single, write a little loop, but for every single SQL statement in the database, I want to generate plan information for. And then you can look at all those plans, and I'll talk about later what are the things to look for that are the most offensive, and then you know what to try to fix. So different columns again on the plan table, I'm going to go through them sort of at a high level. You know, the ID and parent ID is, so when you have a plan, it has many steps. This is sort of how you can link the steps together, and I'll show you the SQL to use this in a minute. You've got the operation column. So this is the actual task that the optimizer performs at this step in the execution plan. And I'll go through all the different kinds of operations in a few minutes, because that's the most interesting. And the options are, so some operations like use an index. Well, you can use different kinds of indexes. Am I doing a unique lookup? Am I doing a range scan? Am I using a bitmap index or a hash or something? So those are different, these are some of the options on the operation. The object name, what is the table? What is the index I'm actually using? The cardinality, so how many records am I processing? And I'll show you, so at this step, how many records, physical records, am I actually dealing with? And then there's different things like CPU cost and I/O cost and how many bytes are processed, and there's a lot of more information. So you can really get very granular to look at a SQL statement and see what happens under the covers. So these are the examples of the most common operations that you will see in that operation column when you actually look at the plan for a particular SQL statement. The most common is using an index. So any operation that uses an index to identify a row ID. A row ID is sort of the unique pointer for a physical record. And the different kinds of indexes I just mentioned a moment ago, you have unique scan. In other words, this is a primary key lookup. I know the key, there's only one record. It's unique. I can bang, go to the index, grab the pointer to the record in the table, the row ID, and bang, I can grab the record. I can do a range scan. So maybe my index is on gender, male, female, and I'm querying everybody who's male. So I'm going to look through lots of data, so I'm scanning over a range, because there's not one male or one female in the thing. A full scan, so in other words, I'm actually going through the entire index. I'm looking at every record in the index. And in reality, that's probably not a good thing to do. If you're going to be doing that, since there's one-to-one correspondence between indexes, rows, and table rows, hopefully, otherwise you have a corrupted index, you may want to say, all right, well, if I'm doing a full scan on the index, I might as well just do a full scan on the table, because not only will I have this column I'm looking at in my where clause, but I'm probably going to be fetching data anyway from those records. And skip scans, and there are other things. merge joins when I'm basically taking two sets of data. In other words, I'm taking data from one table and data from another table, and I'm now trying to merge and do a join. So this is where your actual joins happen. So in other words, if you have a join in your SQL statement, which is very likely, then you're going to do some sort of merge join operation. And typically, you'll just have a plain merge join for an inner join. You might have an outer join, which you guys understand, or you may have what they call a Cartesian join. And I'll explain that a bit later, what a Cartesian join is, but that's something very bad. So if you see a Cartesian join, I'll talk about that example specifically, what a Cartesian join is and how you could get it. I think you'll see the SQL statement that might produce that. You'll realize, okay, that's probably not a good idea. Nested loops is probably the most interesting. Nested loops is where you take data from one table and data from the other table and loop back and forth, a loop, for 1 to however many records here, and then internal loops for records here, and that's how you do sorts, and that's how you do different kinds of filters. So nested loops in general can be very expensive operations. And I'll talk about giving lots of examples of when you see a nested loop in a certain scenario, how you can replace it, what you can replace it with an alternate but equivalent SQL statement that will produce a much better plan. And an outer nested loops is even more expensive because you're doing a nested loops with an outer join, so you're now querying, you're now pulling data and generating null data. So it's making your list of loops just potentially much larger. Sorts. So sorts are very expensive as well. So there are different kinds of sorts. So you might produce a sort because I don't want to say too many things because there are questions later, but you might want to you're going to do a sort when you have a group by, or if you're going to have an order by, where the data comes back, it actually matters what order the data comes back. So typically when you have a SQL statement, the database has the right or the privilege of returning data as fast as it can, so it just, whatever data it figures out matches the criterion constraints on your SQL, it will return to you. But if you put an order by or group by, you're now imposing an order, and so it has to do a full sort. And sorts, as you can imagine, when you have very large data sets, can be very expensive. Table access, well, this is actually you're getting the data. So if the data is not all in the index, you actually have to go to the data. So you might be doing just simple access, sample, you may be doing by sampling the data to see what the distribution is. You may be doing using a cluster or hash. You may grab by a row ID, which is what you kind of want to do. You want to actually have the row ID and then just do a simple one record grab. Views, if you're using views. And then there are others. You might have different kinds of filters or concatenations. You might be doing counts on things, intersections and unions, or other possibilities. And you can look up all this stuff online. There's a lot of really good writing. Oracle has a lot of good writing. Other places have good writing to explain. So this is sort of the high level. Okay, so in order to generate execution line, the syntax is really trivial. You just say, explain plan, say statement ID, and you can put whatever ID you want. Go Giants, this is great, it doesn't matter, it's a string. And you just put your SQL statement. And so instead of executing the SQL statement, what the optimizer will do is look at it, parse it, figure out the plan, and store the plan for you in your plan table. And then, here's sort of the standard statement that everyone's been using for history. You're looking at, you're pulling out from the plan table because you're creating a hierarchy of steps, use a connect by prior, and you just basically pull out, and I'll just sort of show you an example of what to do. So this is an example of a plan that's pulled out. And these are the actual operations and options and the physical objects that it happens. And then these are the number of rows impacted for. And I didn't include the specific SQL statement for this, but that doesn't matter. So the first thing I can look at this plan is, at the end of the day, I'm returning 12 rows. Okay? I'm returning 12 physical records as a result of executing whatever this statement happened to be. But I'm initially touching, gosh, I don't know, that's 11 million in my index scan, just ranging over my entire index. That pulls out 76,000-ish records from the table, and I'm doing different access, and then I'm pulling a subset of those, and then I'm doing loops over loops and filters. Ultimately, there are two group bys, things to sort by and apply to. So we're just doing a ridiculous amount of work. And even though only 12 rows get pulled out, the database engine has to scan. Now, a lot of these indexes might be in memory, whatever, but it's still doing a bloody lot of work. So some of the things to look for when you have your plan, majors, are obviously you know, these numbers? Am I going through a lot of extra work that I don't need to? And, you know, am I doing any full table scans? Do I have range scans, which is what I'm doing here, that's not, you know, that aren't sufficiently constrained, or maybe the index isn't built right, or maybe the index is a concatenated index and I'm using it in reverse order or something. Do I have any late predicate filters? So here I'm doing loops and loops, so even though I have subset, I'm just, you know, sorting and resorting and doing all sorts of things. Do I have the wrong join order? Maybe it could be that I have one table that's small and one table that has a lot of data being pulled, you know, and I'm pulling from the big data table instead of the small data table. And maybe I want to use a small data table to constrain how much data I'm temporarily pulling from the big data table. So these are all things to kind of think about. You know, and there's lots of other things which I'll go through as well. We're doing okay. Any questions? Most eyes are still open. Very good sign. Except for Leo, who's, you know, surfing his ears.
I'm taking meticulous notes.
Yes, I'm sure you are. Okay. All right, so now that I have an offensive SQL statement, I found the troublemaker, okay? How do I tune it? So first I understand what the cost is of different plans. So we're gonna kind of dive into details of all those different elements, what they need. I'll determine if the SQL is needed at all. So I mentioned earlier, you know, if I'm doing, you know, something, you know, the same statement over and over and over again, maybe the application should just cache the data, you know, then I have it locally, you know, in my memory, and I don't even have to ever go to the database. So that might be an option as well. And then I want to identify some path for a new plan. So should I do something simple, maybe just add or modify an index, or, you know, change the underlying tables, denormalize the tables, create a materialized view. There are lots of different options of things that I could do. Or maybe I should spend time rewriting the SQL statement itself. So these are all sort of high level things to do. So what are possible tuning fixes? So let's talk a little bit about some of the possible options we could do. So the optimizer uses statistics on the table. It understands for each table, it takes sample data, it tries to understand the distribution of data both for the key columns as well as the non-key columns for whatever might be secondary key columns. So it keeps these statistics working. So it might very well be that the statistics it has are out of date or unbalanced. So maybe it's just a matter of refreshing the statistics on a table. That might be a possibility. And there you use the analyze tool, which is a SQL analyzer, in order to analyze a table or analyze an index. That's a possibly good option. Maybe you just rebuild an index. An index may become very unbalanced. So we'll talk a little bit more about indexes and what they look like and how, you know, what different kinds of indexes are available. But the index itself, you know, depending on how often you add and remove data from the table, it might fragment a lot, it might have lots of nodes missing in B tree or not. So those are all possibilities. There is actually a tuning wizard, at least Oracle has one, so you could actually just say, all right, I don't know, I sort of half paid attention when Steve was talking, you know, that day in January, and I don't remember most of what he said, and it was on some slides, and I know the slides were on the website, but I forgot to download them, so I have no idea about any of this stuff, and I don't remember. Well, Oracle itself has a tuning wizard, so you could ask Oracle, hey, what would you recommend? And in many cases, it might come up with a very good answer. So this doesn't mean you should stop paying attention now. You should continue to pay attention, but that's one very good option possibly. The other thing is you may say, all right, this statement is good, but I'm smarter than the optimizer. So you might be. The optimizer makes mistakes. Everyone makes mistakes. So what you can do is you can say, all right, optimizer, I'm going to give you some hints. You're not so smart. Oracle spent only hundreds of millions of man hours, you know, developing you, but I know more. So you can actually give the optimizer a hint. It's part of the syntax of your select statement, and there are lots of different kinds of hints. There's probably 20 different kinds of hints. And you can give the optimizer a hint and say, you may think you know well, or you may have statistical data, but I know in reality this is how my data looks, and this is the best way to go about doing it. You know, use this table first, or use this kind of inner join, or outer join, or an anti-join, or all sorts of different kind of things.